the geometry lesson 6.3 on triangle angle similarity theorem. So today, 6.3 and 6.4 go over the 3 different triangle similarity theorems that determine, or that can be enough to determine whether 2 triangles are similar to each other. So they're kind of like the triangle congruence theorems, except for here it's similarity, and we check to see if sides are proportional rather than congruent. But it does in fact say that if you have two triangles that have congruent angles, then you know that they are similar. So we're going to do a little investigation here in GeoGebra. And if you are in my class, then you have the paper that goes over these directions. But if not, you can just follow along. So we're going to go to geogebra.org/geometry. And I wasn't planning on sharing that. Okay. So then we're going to do, it says use the polygon tool to graph triangle ABC with vertices 0, 0, 12, 0, and 8, 9. So I'm going to kind of move my graph over a little bit so that it encompasses those points that I need. Okay. And I'm actually going to also zoom. Well, I don't like zooming out like that. So I'm going to hide this. Okay. So 0, 0, and then 12, 0, and then 8, 9. And then back to my starting point. And then it says graph triangle XYZ by doing the following. It says create XY, segment XY with vertices 4, 1 and 8, 1. So 4, 1 and 8, 1. And remember to change the coordinates. We click on the move tool and we click on the letter, click on that, and then change that to X. And then click on this, change it here, and change that to Y so that the coordinates match up. And then it says draw a line segment from X that is parallel to AC. So if you look at AC, if it's parallel, it has to have the same slope. So AC goes up 9 and over 8. So this has to go, if I drag this up a little bit, I'm going to make a segment that goes from X and it goes up 9. So that would go up to 10, and then over 8, so that would go over to 12. So that would be parallel to this. And then we're going to, and that's the smallest segment we can make that would be parallel, because, right, 9/8 doesn't simplify it anymore as a fraction. And then draw another line segment from point Y that's parallel to BC. So BC, we're going up 9 and over 4, from 12 to 4. So from here, from Y, we're going to go up 9 over 1, 2, 3, 4, like that, from 8 to 4. And then what we've done here is we've made a triangle, and we're going to label this as Z. So we click on the point tool, intersect, and then label it Z. But what we did is with parallel lines, because we know that these are parallel. So with parallel lines, we made sure that this angle here, angle A, is going to be the same as angle X, and angle B is going to be the same as angle Y. And you can check that by using the tool. So it says, does each pair have the same angle measure? So you would use the measure tool. So click on more, and then measure, angle, and then click on you have to click on the vertices in the same order. So if we want to measure angle A, you click on CAB, and then that's 48.4, and then CXY is 48.4 as well. And then you would measure the other B and Y. So CBA is 66, and ZYX is also 66. So we've made a triangle in such a way that those 2 angles are congruent. And this means by the angle congruent similarity theorem that the angle measures are preserved, and then the triangles are similar. But it also says in the description for part B, what else do you need to prove that the triangles are similar? Well, you need to check that their sides are proportional. So that's what you would say for that. Then it says to use the measure tool to show that the triangles are similar by comparing the ratio of the corresponding sides. So you click on the distance or length tool, and then you're just going to measure the distances. So AC is 12, XC is 4. And then CB is 9.8, ZY is 3.3. And then AB is 12, and XY is 4. So all of those would have a ratio of 12 to 4 or 4 to 12. So that would be 1/3 or 3. So then it says, what is the scale factor that takes ABC to XYZ? You would say 1/3. Because you'd have to multiply this side length by 1/3 to get this side length. So let's move on to the lesson. So it says the angle-angle similarity postulate says that if two angles of one triangle are congruent to two angles of another, so if two angles of one triangle are congruent to two angles of another, then the triangles are similar. So it's kind of a shortcut for proving that triangles are similar, just like our congruence theorem shortcuts. So here, I guess this is just showing an example. Let's say triangle JKL is similar to triangle ZYX because we know that K and Y are congruent, and then J and Z are congruent. So if we know that the two angles are congruent, then we know that the triangles are similar. And then the next part says determine whether the triangles are similar. So for number 1, this says 92 and 57, but this says 92 and 41. So you want to figure out the third angle and see if any of them match up. Let me make this smaller. Maybe. Okay, so if I did 180 minus 92 minus 57, I get 31, not 41. So no, the angles don't match up. There aren't at least two angles that are congruent, because if there was, there would be a third one, obviously. So this would be no, not similar. And for number 2, I see kind of the same thing. So we want to subtract the one from 180. So we would do 180 minus 77 and then minus 48. That would give me 55. So this angle here is 55. So we have 48 and 55, 48 and 55. So yes, they are similar. If so, write a similarity statement. So we would say triangle, we could say ABC, similar to triangle, and then that would match up with, this would be 77. So that would be D and then EF, because we have to list the vertices in the same order that they are congruent. For this one, if this is a 90-degree angle and those are both congruent, then they both have to be 45, because if you subtract 180 from 90, you get, and then divide by 2, then you get 45. So these are both 45, which means that this is an isosceles right triangle. Now this is also an isosceles right triangle, which means that these two angles are going to be congruent, and again 45. So yes, you do know that at least two angles are congruent, and so then we can say triangle. We'll do the same thing, ABC, similar to triangle, and then it doesn't matter which one you put first. You can put D or E first. We'll just say D, E, F. Just be careful because it won't always be alphabetical like that. That's not guaranteed. Number 4, which triangles are similar to triangle EFG? So EFG, well, this would also be 70. And if that's 70, then these are 140, which would make this angle G 40 degrees. So this angle is also 40, so this would be similar. Because if that's 40, then you know that these two are going to, and this is an isosceles triangle, then you know these two are going to both be 70. If that's 70, then that's 70, so that's going to be 40 again. So that is similar. And then for C, well, this is 45, and if you do 180 minus 45, you get 135. If you divide that by 2, well, you don't get 70, you get 67.5. So this one's not similar. And then the next question, explain why the two triangles are similar. So these are similar because they are equilateral, and equilateral triangles all have measures of 60 degrees for the 3 angles. So equilateral triangles have measures of 60 degrees. And you only need 2 angles to be similar, so these would be similar, even though they don't have the same side lengths. They have proportional side lengths. For number 5, let's see. Well, here, if this is 90, then this is also going to be 90, because this is a linear pair, and 180 minus 90 is 90, so this is also a right triangle. So if you do 90 minus 62, you also get 28. And then over here, you can do the same thing. So this would be 62. And I guess by showing that and explaining that, you can write that on your paper if you want, but that's how you would prove that it's similar. So for number 6, well, for number 6, you're looking at this triangle and then the triangle outside of it. So since you know that these are parallel, you also know that you have corresponding angles. So I'm actually going to erase this so we can see a little bit better. But whatever that angle is and that angle, those would be congruent. And then this Q and the R would be congruent. So you know those two. You also even know that this angle S is congruent to itself because of the reflexive property. So you could say that the measure of angle S equals the measure of angle S from reflexive property and you could also say that you could just say that they're congruent too. You can say that angle RTS is congruent to angle QUS. I'm assuming that's a U. It might be a D. I don't know. I guess it's a U. And that's because of corresponding angles postulate. Corresponding angles postulate. If you know that 2 lines are parallel, then the corresponding angles are congruent. And that's how you'd prove that they are similar. So now we have some other problems here. Some word problems. It said a building casts a shadow that is 78 feet long. So here we've got 78 feet. And then at the same time, a nearby signpost that is 5 feet tall casts a shadow that's 39 inches long. How tall is the building? So the things with a shadow is that when you have a shadow, it actually creates angles that are going to be the same. So this angle here is going to be the same as this angle. And since they're both, we're assuming at a right angle, I guess it shows us that, then you do know that the triangles are similar. But in order to compare them, we have to have the same units. So one thing we can do, is convert them all into inches. So 5 feet would be 60 inches, because if you multiply by 12, and then if you do 78 times 12 would give you 936. So then you can do a proportion here. So you can say x divided by 936 equals, so that would be 60 over 39. 60 over 39, I might simplify that first before multiplying. I know they're both divisible by 3, so that would be 20 over 13. So if I cross multiply, I get 13x equals 20 times 936 is 18,720, and if I divide that by 13, I get 1440, and if I divide that again by 12, I get 120. So 120 feet is the height of the building. Okay, for part B, it says, suppose a different building casts a shadow that is 52 feet long. So you would do the same thing, multiply 52 times 12, which would give you 624, and then you would do x over 64, or 624, equals 20 over 13. And if you solve that, that would give you, and divide by 12, that would give you 80 feet. So kind of the same setup there. Okay, so for this one, it says you and a friend are standing next to one another outside. Your shadow is 23 inches long and your friend's shadow is 24 inches long. You are 5 feet 5 inches tall. If you do 5 feet times 12, you get 60. So plus another 5 is 65. So you're 65 inches tall because we want to have everything in the same units. So you could do your friend, which is x, because you want to know how tall they are, divided by their shadow's length, which is 24, equals 65 over 23. And then if you cross multiply, you get 23x equals 65 times 24. 65 times 24 is 1560. And if you divide that by 23, you get 67.826. Now, in order to convert that back to like feet and inches, you would do divide it by 12 again. So that gives you 5.652. So you know you're 5 feet. And then if you take that and subtract the 5 and get the decimal and then multiply the decimal by 12, you get how many inches are left over, which is 7.8. So you could just round that to 8 inches. So 5 feet and 8 inches tall is how tall your friend is. And you would expect them to be a little bit taller than you because their shadow is longer. All right, so that's the end of this lesson. Hope you guys have a great day.